Thank you for everyone for joining us for our latest webinar. The Institute for Carbon Removal Law and Policy focuses on social science aspects of the emerging field of carbon dioxide removal, including issues associated with law, politics, and ethics. And we're pleased to host a webinar today that focuses on a critical issue as we discuss the role of carbon dioxide removal in a portfolio of responses to climate change. While many have acknowledged that there may be an important role for carbon dioxide removal to play in addressing climate change and meeting the objectives of the Paris Agreement, there is also a substantial concern that a full-throated commitment to these options might ultimately result in a diminution of commitment to aggressive decarbonization of the economy. Some term this a moral hazard, others term this mitigation deterrence. And today we have a panel of three excellent scholars to discuss that issue, as well as potential policy recommendations of how to address this issue. Niels Markussen, Duncan McLaren, and Rebecca Willis are with the Lancaster Environment Center at Lancaster University in the United Kingdom. And they are going to present the results from I believe it's a 3-year project that is called Assessing the Mitigation Deterrence Effects of Greenhouse Gas Removal Technologies. And logistics for this webinar will be as follows. The three presenters will make brief interventions, and then we'll follow this up with a question and answer segment at the end. And so with that, I'm going to turn it over to Niels to begin the presentation.
Thank you, Annalise, and thanks, Will, for having us. I'm going to try and share my screen here now. There, is that working? Yeah, thumbs up from Will. Thanks, Will. So, so we will deliver a topic here today for us is delivering greenhouse gas removals without undermining mitigation. And as Will said, this is the findings from a project of ours that we have been working on, which is called Assessing Mitigation Deterrence Effects of Greenhouse Gas Removal Techniques, the AMDEC for short. So it's me, Rebecca, and Duncan talking today. We've listed here also our other collaborators in the project here at Lancaster University, and we have a longish list of the funders who've been kind enough to support our project. So the outline, so the structure of the talk today is that I'm going to start by explaining a little bit about, very briefly introducing greenhouse gas removal and why it matters, and also a little bit of what we mean when we say mitigation deterrence, and give some examples of that. I will be handing over to Duncan, who will give some historical background and some quantitative estimates of how serious mitigation deterrence effects might be. I'll come back and talk a little bit about the theory and behind this, and some of the methodology we used for the main part of our project, which has been a deliberative exercise. We run a set of workshops with people. Duncan will then come back and present results from that part of the project, and finally Becky will explain to us what all this means, what implications it has for policy, not least. So how we can use DGR safely whilst minimizing the risk of undermining other mitigation efforts. So, GGR has really come into policy focus at the same time that climate policy has been framed as through carbon budgets. We know that the safe budget for carbon emissions is almost exhausted. We know that really rapid decarbonization is essential to stay within safe limits for the climate. We know that GGR is almost certainly needed in addition to mitigation, and this is the key to our project: how to make sure that we get both, that we get GGR in addition to to mitigation. One plausible estimate from 2020 is an estimated remaining budget of 80 to 176 gigaton carbon. And that's what we've used in our quantitative side of our project. So what do we mean by GGR? And GGR is a UK kind of acronym, greenhouse gas removal, very similar to carbon dioxide removal, carbon removal, nets technologies, etc. We define it as the large-scale means to remove greenhouse gases from the atmosphere and sequester the carbon that has been captured. In our project, we have focused mainly on 4 specific GGR technologies, GGR techniques. So BECCS, so biomass, carbon capture and storage, enhanced weathering, soil carbon enhancement, in a few different kinds, including biochar, for example, and finally direct air capture. It should be noted, though, that we've also looked at GGR as a category in itself. So GGR as the umbrella category, capturing all the different, as it were, encompassing all the different GGR techniques. Because we're interested in not just the physical material impacts of impacts of a technology deployed somewhere, but also the discursive impacts, the effects of just talking about it. And GGR as a category in itself has had an impact on policy. So why are we talking about all this at all? So quite oftentimes we talk about climate policies, the technologies used to respond to climate change in climate policy as additive, as just things you can add together as wedges, etc. And of course, we need multiple technologies. We do need to use them together, but we need to be quite savvy on how they interact. And we're quite good at understanding some of those interactions. So we think that in normal modeling work and analysis, we're quite good at understanding economic interactions, least cost solutions, for example. We're quite good at understanding some of the physical interactions, land use competition, and things like this. But there are other kinds of interaction effects, we think, cultural, political ones, that are typically not well modeled and that also matter. And they matter not just in terms of impacts of deployed technology, but also before deployment, already during development, demonstration, testing, etc. The mere talking about GGR technologies matters culturally and politically, so that we need to understand those kinds of interaction effects as well. And these kinds of interactions happen, importantly, they happen on a playing field that isn't even, it isn't level, as it were. It is quite heavily influenced by vested interests, some of which are rather skeptical of mitigation efforts and the need for it, and the need for it. So GGR promises are partly uncertain, of course, right? Like any new venture, any new technology development. But they could also trigger some unexpected perverse effects. We worry about that. So the effect that GGR technologies might have on mitigation through these other kinds of interaction effects, cultural, political, etc. And it's important here to emphasize that this is not us arguing against GGR. We are convinced that they are very necessary and important. What we really want here is to investigate under what circumstances GGR can be used safely alongside other kinds of mitigation. How can we get both when the risk is that we get neither, that we both undermine other kinds of mitigation and risk failing getting GGR as well? So how to get both rather than neither. With that, I hand over to Duncan to talk about historical background and quantification of mitigation deterrence effects. Thank you.
Thanks very much, Nils, and welcome everyone. Pleased to see you all in virtual reality at least. Starting not so far back in history, just really last year with an example of what we see as a form of mitigation deterrence. You'll probably all remember the rather high-profile article in Science that billed tree restoration as the biggest single solution to climate change. Some of you may have been involved in rebutting those claims. Several people were published a few months later in Science showing how this had been overestimated. Now, the claims might have been genuine errors, but they gained a life of their own. They were not just supported by figures like Greta Thunberg or Cristina Figueres as a supplement to other climate measures, but they were adopted as a smokescreen for Trump's ongoing opposition to other measures. Indeed, his ongoing support for the coal industry stood side by side with a promise to join in the Trillion Trees initiative. In the UK, a government minister defended bailing out a failing airline on the grounds that it had already decarbonised by supporting tree planting. So we saw a problem of an exaggerated promise of what tree planting could do flow within a few months into an influence on policy and potentially on public attitudes. But if you could move on the slide, please, Nels. Our sense is that this is that's a provocative example of recent deterrence, but mitigation deterrence is actually quite systemic here. And another case that you may well be familiar with is that of bioenergy with carbon capture and storage. In reality, if we look around the world today, BECCS is a niche application, a niche technology. There's a few plants applying it to ethanol fermentation, where it captures about 15% of the carbon from the biomass as CO2, pipes it off to a oil field where it's pumped into the existing oil field to generate more profitable oil extraction. So that's not really doing anything for the climate, but embedded in climate models and in the integrated assessment models are huge amounts of BECCS in a different imaginary form, an imaginary which is of a 90% capture, 90% capture of carbon dioxide from the combustion of biomass, pumped into a long-term geological store where it is safe and secure for thousands of years. That model of BECCS has a few small-scale trials going on, but this is actually just what we've seen for a decade or more with trials of CCS on fossil fuels, where things perhaps got even worse with the promise of capture-ready plants. So fossil fuel power stations that had a piece of land next to them, perhaps a big car park, on which a capture facility could be built, but wasn't necessarily going to be built. And in fact, we've never seen one of those built. Those promises, though, of capture readiness, of CCS on fossil fuels, help to delay the replacement of fossil plant with renewables. In the models, things get even worse because the promise of BECCS embedded in the models in quite large quantities disguises a slower reduction in emissions in the models that don't, compared to the models that don't have BECCS. The models prefer more imaginary future technologies over near-term action because when it's the discount rates in the model are applied to the costs of future carbon removal, it seems cheap. On the other hand, the uncertainties involved and the potential side effects aren't modelled very well, and they don't tend to appear in the models. So we have fortunately seen again this sort of robust pushback from science as to why there are problems with BECCS, but there is still a large amount of negative emission technology embedded in most of the pathways, most of the models we see today. So if we could move on the slide. What we see, or what we argue there, is that BECCS is a great illustration of how different technologies co-evolve with climate politics and climate modelling. the idea of BECCS both needed and helped stimulate a shift in how we thought about climate targets. Because BECCS only does a very little bit of emissions reduction. On the other hand, it works or appears to work very well at affecting the outcome concentration of carbon in the atmosphere, or in modulating how we meet or don't meet a carbon budget. And it's in that difference, that shift from emissions reduction percentage to budgets or atmospheric concentrations, that GGR finds a big space in policy. And the extension of integrated assessment modelling, which happened in parallel with this, to model carbon budgets, has allowed other speculative future GGRs to influence apparently plausible pathways too. And that's, we explore that in a little more depth in a piece published last week in Nature Climate Change. If you could flick on the slide, I'm going to try and summarise that heroically. I was just telling you about the paper last week. What we do in that, and this is summarising heroically, is identify these 4 phases in how people have talked about, considered policy targets. And we see here a pattern that we think is rather more than coincidental. Each shift in the framing of the targets permitted more flexibility in how technologically the targets could be met, but in turn also more delay in awaiting the delivery of those promises. So from the early days, the promises of huge amounts of nuclear power, only a tenth of which or so was ever delivered, then the promises of CCS into BECCS, more recently other GGRs, and worryingly now solar geoengineering techniques like stratospheric aerosol injection, which don't fit in a framing of emissions reduction or a framing even of carbon budgets, but do fit framings of achieving a particular temperature outcome, which is the current framing that we use most predominantly. Now, I think it's really important to stress our analysis does not rely on this being a deliberate thing that has been done in some deep conspiracy. What we find is that the way the models and the politics and the technological promises interact generates this as an emergent systemic problem. So to summarise and offer a definition of mitigation deterrence, we use this, the prospect of reduced or delayed emissions reduction resulting from the introduction or consideration of another climate intervention. So no, we're not just talking about GGR, but interactions between interventions. So nuclear promises could and probably did defer action on energy efficiency or renewables. Behavioural promises, the idea that we're all going to stop eating meat, for example, could deter people from investing in GGR development. We're not denying that sort of possibility. GGR is, however, unusual, and we think more pernicious in this respect, in that it promises to work like a time machine. It offers the potential or the promise of recovering past emissions, not just slowing down future emissions. So it can have a deeper and more impactful effect on delay. Also, we think it's worth noting, and we'll mention the moral hazard term as in his introduction, we've deliberately moved away from that, partly because we think people hear moral hazard as a personal criticism when you say your work might be generating a moral hazard. But more importantly, because we see mitigation deterrence as a collective, emergent phenomenon in conditions of deep uncertainty. Whereas moral hazard in the literature that it came from, the insurance literature, is about decisions by individuals in the face of known risks and expectations. So One question that you quite legitimately would ask is, how serious could this problem be? Is it actually just something marginal that we don't really need to worry about? To assess this, as part of the project, we developed a novel carbon at risk approach, based on carbon budget modelling. These three types that you see defined on the right, therefore, are defined this way partly because that makes them quantifiable. And we understand some of the irony in doing that. But this gave us a way to put a numerical handle on it, which we hope helps those who find numbers useful and manipulable. So type 1 asks the question of how much GGR the models anticipate, and speculates as to what if it goes on being promised but isn't delivered or fails. So, for instance, if we do get direct air capture, but we just use it to create synthetic fuels in carbon utilisation. Type 2 assesses what happens with that much attempted GGR, what sort of rebounds might arise. For example, from land use change, if there's a lot of BECCS going on or a lot of biochar. And type 3 asks, well, what if people listen to these exaggerated promises too much and expect more GGR than could be delivered, hold off on doing the more expensive things that they might otherwise do to mitigate? And to do this, we use a calculation that focuses on remaining emissions reduction that would cost over $100 per tonne of carbon dioxide. So that puts it in the competitive with even quite expensive promises of GGR, and certainly well undercut by promises like 50 cents a tonne for huge-scale tree planting. So how do we get to a number from this? Well, those three types are additive. We can add them together, but you should note that the quantity at risk in type 3 is inversely correlated to that at risk in type 1. So when more substitution is planned, type 1 carbon at risk, there are fewer remaining expensive mitigation expectations, so there's less type 3. So that's why the numbers run in opposite directions across the low to high estimates for those two rows. Our central estimate here adds up to almost 500 billion tonnes of carbon at risk. And that implies an additional 0.7 degrees centigrade at a median estimate of climate sensitivity. So that's if all other things were equal and we were going to achieve 1.5 degrees C, that means the outcome would be 2.2 degrees C. That's bad enough. The worst case, at a high sensitivity, would imply an extra 1.4 degrees C. So I think we can conclude that it isn't marginal, that the worst case is bad enough that we should take it seriously. Here we're sort of taking a little step back and saying, well, what's the theoretical perspective that we've used here? How should we understand the construction of futures with these huge amounts of carbon removal? Is it the result of some sort of objective need that somehow elicits or draws out, encourages the development of a new technology to meet that need? Or is it, on the other hand, the result of a cultural way of life, a fossil-dependent way of life, fighting for its survival by inventing new imaginary ways to solve the problem of climate change in the future? I give you those two just to illustrate that there's such broad, different possibilities here. We've applied a frame of what's called cultural political economy, which accepts that, as Neil said earlier, there is power in promises, there is power in narratives and discourses, a constructivist way of thinking about technology that's widely used in science and technology studies. But CPE attempts to reintegrate ideas of materiality, the fact that there are robust things that are real and physical. And for instance, that the Earth system itself is recalcitrant. We can't just imagine the effects of climate change out of existence. CPE also recognises that the political economy of interest groups, and particularly financial interests, and it sees political regimes such as in the current neoliberal version of capitalism mobilising what we call, the literature calls, spatio-temporal fixes to sustain that regime. It understands those regimes as co-evolved with social imaginaries, which encompass broad but conditioning understandings of how the world works, how society works, what is and isn't feasible. And it sees new technologies as inextricably embedded in the co-evolution, not just of promises and applications, but also of those encompassing policy and political regimes. So this cycle of things that you see on the left of the screen. And we use that understanding to try to open up the possibility of different political futures, which we, as you'll see in a moment, we then used as a frame for deliberative workshops to stimulate discussion about what might happen. And we set up these sort of set of fairly traditional 2x2 matrix to help us analyse this world through deliberation. So our scenarios map out futures, one in which things sort of muddle on, or two in which neoliberalism is revived, partly in a new Chinese-led model delivering strong markets, or in which the current populist trend accelerates into authoritarianism, delivering what we call strong leaders, or alternatively, in which that trend is reversed by a progressive backlash, delivering a more egalitarian politics with strong publics. I've deliberately talked there about strong markets, strong leaders, strong publics, to suggest that these are, to some people, each of these is a sort of utopian outcome, is a desirable political setting, one in which they believe we will make good progress on dealing with the problems that face society. We use them to consider how GDR might play out in each of those scenarios. Each scenario also has had a number of variants to explore different technologies, and we discussed these across 9 workshops. 5 of them were face-to-face, 4 of them were virtual, so we got an international audience. In each workshop, we contrasted 2 political contexts. So everyone got a sense of, okay, this is how it might happen and what might go wrong. And then we're challenged, given a possibility to consider a completely different political scenario and other possible ways, in fact, in which things could go wrong. And we laid out the scenarios across the period between now and 2050. So in these discussions, what did we find? We've written up these findings, but they're under a review, so you're getting a sneak preview at the moment. We did see in the discussions all of the mechanisms identified earlier, not just as sort of abstract risks, but also in the ways that some participants approached the discussion and talked about these issues. And the speech bubbles here are direct quotes from different participants, in some cases referring to specific industries. What we found was that people wanted to move beyond just mechanisms, and understandably so, and explore the drivers of why these things might happen, and discuss a deeper take, in a sense. And in particular, we heard or saw these 3 things that we've pulled out from the data or from the transcripts as drivers. First being this shared understanding of how the world works in a form that makes it difficult to imagine or difficult to reject substitution and trade-offs, even across time. And as I've put it on the slide, it's this idea that it's easier to imagine the end of the world than the end of capitalism. Even in scenarios where perhaps the end of capitalism was being hinted at, people still found that hard to imagine. The second is that people found or identified and talked about the remarkable political traction of exaggerated claims and promises, as we see, of course, in the news every day with the power of fake news. And people very frequently came back to and restated the insidious impacts of vested interests working to short-term financial incentives. So again, we've got some direct quotes there, like a market is to make money for the traders, it's not to reduce emissions. Under that understanding, it's very difficult to see why mitigation deterrence would not arise. But there were also objections, and I'm sure that amongst the audience today, there's people going, but what about? And you may have some of these in mind. We heard several of these repeated, that GGR is needed as well as emissions reduction, and that somehow that meant there was no risk of the two being substituted, one for the other, or that GGR is more expensive than emissions reduction, and that therefore there would again be no substitution, or that someone would do something, that decision makers would forestall serious deterrence or substitution. And there is truth, of course, in some way in all of these. But when stated this boldly, I think it's clear how they are perhaps more reflect perhaps a naive rationalism and an assumption that people and decision makers make decisions on the basis of the best evidence, which is rather at odds with the post-truth culture we find ourselves in. Similarly, they reflect that social imaginary that we talked about, the perhaps neoliberal or liberal administrative social imaginary, which, as we saw with the cases of Becks and tree planting, is vulnerable to mitigation deterrence. So our objective here, as Nils pointed out, is to help deliver both GGR and emissions reduction. And our work here, I think, begins to surface some of the risks that in practice, without recognition of the problem, there would conflict, there would be substitution. And if we allow substitution in models and markets, if we enable exaggerated promises and hype, and if we rely on others to deliver rational decisions, then those risks grow. We did in the workshops, because we had the mix of technologies and political settings, we were able to assess whether any of them were more or less vulnerable to these problems. Sadly, and to put it briefly, the broad answer is that all of them seem to be vulnerable, although the mechanisms differ. So some technologies suffer from some mechanisms, others from others. Some political regimes suffer from some mechanisms, some from others. Now, that's probably all very depressing, and I'm now going to hand over to Becky to talk us through the final slides, but with definitely a bit more hope.
Thank you, Duncan. So it's my job to cheer everyone up. I'm going to be really brief, actually, because I do want to. I'd really like to hear your comments and questions. And I've already seen a comment from Frank in the chat box that could it be that the challenge is overwhelming, and so everyone wants to sort of see a way through. And yes, absolutely. And one, the main finding from our point of view is that we absolutely need to take the possibility of mitigation deterrence seriously and stop hiding behind this idea that a sort of rational economic man view of the world is guiding things, that there are very complex cultural, social drivers for these technologies and particularly the modelling. So we need to take the problem seriously. We also need to recognise that those issues, those problems of mitigation deterrence will be embedded within models and within policy presumptions and within all of us actually in our roles in the policy and research domain. So actually bringing those to the surface and thinking about them, thinking about what we can do about them is really, really important. We found the deliberative approach, doing these deliberative workshops with stakeholders, really effective because it did give people the chance to interrogate their own assumptions, interrogate each other's assumptions, and really unpack and foreground these issues. Next slide, Duncan. So what can we do about it? We think that the main thing, and you'll hear this in this slide and the next, is this idea of separation. So we think that you need greenhouse gas removals and reductions, and we think that if you have a separate strategy for both, then you have maximum chance of maximum chance of succeeding with both, and you're going to limit the possibility for negative interactions. So you actually have strengthened delivery of greenhouse gas removals alongside separate focus on reductions. As part of this, I think we really need to address the issue of incumbency and think, and again, be very upfront about the power of vested interests and incumbency on the process. And part of that is really to call out the promises that are made and to really ask whether those promises are realistic. So let's flick on to the next slide and I'll do the absolute headlines of our policy proposals. Last slide, Duncan. So our headline policy is that of substitution, and there's a paper specifically on this that you'll see referenced there. The idea is that if you separate out targets, accounting, and policy for greenhouse gas removals compared to reduction, then you get a much clearer picture of what's going on. And actually, probably the reason that those two have been mixed together is exactly because it's convenient for policymakers and it's convenient for vested interests to be able to hide one behind the other. So we think if you separate the two, it makes it much harder to hide failure in reduction by claiming removals either now or in the future. The other advantage of separation is that you then can provide dedicated support and policy support for carbon removal technology. So you give them the best chance to prosper by actually having targeted policies on them. So one strong implication from this is that a simple carbon price which applies both to removals and reduction and which allows for trading in between those probably isn't going to be effective, or at least it isn't going to be effective unless you have very clear separated policies, targets and accounting for those two different types of action. So that's very, very different from the sort of straight economic view that if you get the price right, the solutions will come to the fore. We think as well that there should be an official recognition of mitigation deterrence, and it should be named in strategies, and there should be policies to overcome it. And lastly, we think that if you look at the scope of research that there has been on greenhouse gas removals, we think that there's been much more in terms of economics and scientific and technological feasibility than there has on some of these underlying cultural and social and political drivers. And yet through our workshops we realised, and people in the workshops realised, how incredibly important these underlying drivers and assumptions were. And the more that we can do to bring those out in the open and talk about them honestly, the more likely we are to be successful in getting carbon removals right, making sure they are part of the solution, but that they don't take away from the greenhouse gas reduction measures that we really need. So I've whizzed through that because I really did want to get a chance to hear your questions. But yes, please let us know what you think. Thank you.
All right. Thank you very much to all of you. We have a few minutes for questions, and I'm going to try to field some of them that are in the boxes, including any that might be directed to one of the specific speakers. So this is a question for any three of you. You mentioned before that mitigation deterrence can work in the other direction. That is, promises of decarbonization can result in reduced work on GGR. Why not quantify this as well, or try to quantify this as well?
Shall I have a first go at that? So I think there's two reasons, and neither of them are to say that wouldn't be an interesting topic. It would be an interesting topic. But the two reasons are that we feel a normative responsibility to examine where something could be extremely problematic over examining something that would be a nice bonus. So we're looking at the risk side seriously, rather than necessarily the possible synergies. The second is that, and I think if I understood the question correctly, asking about deterrence of GGR by mitigation promises, that at the moment the balance is very much that the GGR things that are being promised are much more uncertain than in other emissions reduction promises in their level of technological, commercial, social certainty and acceptability. So the risk on that side, I think, is significantly smaller. However, as I said, it would be an interesting question with the capacity to go on and research further.
Okay. Anything to add to that, Becky? Okay. So we'll move on to the next question. This question suggests why is there an emphasis here on BECCS and DACs, given the fact that so-called regenerative agricultural solutions such as no-till ag, biochar, permaculture, agroforestry are well developed at this point and include sound measurement methodologies.
I think, again, I'll take a first stab, and Nils or Becky can add. I think that's an artifact of the way we've presented today. So soil carbon recovery, soil carbon storage was one of the four technologies that we looked at in depth, and we ran workshops to discuss, and we found deep problems there, particularly with the levels of uncertainty about the long-term storage, and particularly with the ways in which it would be incredibly difficult to monitor that. And I don't accept the assertion that these things have effective monitoring methods so far. They have possible monitoring methods, but not ones that are robust in the face of deliberate efforts to distort, as we have seen with all agricultural subsidy regimes. So unfortunately, different types of technology do not escape the problems. They suffer different mechanisms, as we said. And our study focus, we chose the four technologies partly because they were technologies or techniques that were under consideration elsewhere in the UK programme that was funding our work. So that's quite a sort of sample of convenience in a sense, or because we thought that we were aware of promises that they were hugely scalable. So that was why DAC came in. The other three were already in the programme, but also have faced those same promises that they're hugely scalable. And I think all of them are questionable on those grounds.
All right, thank you for that. I believe Nils is back with us. We've lost Becky now. Anything to add, Nils?
Yes. I think so. So, I mean, yeah, just to agree with Duncan, we certainly included other technologies as well. One reason, though, I think why it's easy that BECCS comes to be foregrounded here is that we have more history of it in terms of being included in modeling, being given attention in policy, etc. And it's better studied already before our project even. So it's an easy thing to talk about. But we have included other technologies in our project as well, for sure.
All right, thank you for that. Next question. Separating mitigation and GGR policy regimes seem difficult enough, but maintaining separation between them in the long term seems even more difficult. What thoughts do you have on the problem of maintaining separation in a practical sense?
Do you want me to take that?
Yeah, have a go, Becky.
Sure. I mean, I think I think the
Well,
particularly important is the timescale issue. Essentially that you can use greenhouse gas removals as a time machine to make promises in future.
I think one of the best examples we've seen of a model that could be effective here is the way the UK has used its Climate Change Committee to provide advice on continuing budget periods, and if, as long as in each of those budget periods of 4 or 5 years in length, the distinct contributions of emissions reduction and greenhouse gas removal are being targeted and documented, and ministers can be held to account on each of them, then that degree of separation can be sustained. It may be that once some GGRs are well established and we are much more confident about the scientific knowledge about how uncertain they are, that we're going to be less worried about the strict separation. But that to get them started, it seems very clear that they need these dedicated support mechanisms and a strict separation.
Okay, thank you for that. Next question. Given that we've basically used up our carbon budget, I think the time machine argument is not relevant at this point. How would you respond in that context?
I mean, what we uncovered throughout the project was a very strong sense that people felt that policymakers in particular were relying on removals in order to do less on reduction, and I think we need to be really upfront about that. And I think that the example that Duncan gave about the Nature article, the Trillion Trees discussion, is a really good idea. Is a really good example.
Okay, thank you for that. We have time for one last question, I believe. Could the panelists discuss GGR and the prospects of mitigation deterrence in the context of the Sustainable Development Goals?
Okay. Hi, Nils here, trying to make some contribution in spite of technical problems here. Well, one basic insight in this project is about a key mechanism for mitigation deterrence is substitution, right? So typically through markets, but potentially in other ways, how it could substitute for, so how GGR in the future primarily would substitute for mitigation, other kinds of mitigation, emissions reductions in the short term. That sort of substitution is facilitated by narrow framing, the simpler representation of the technologies and their impacts and their function you have, the easier it is to substitute. The more you take other kinds of impact, side effects, other kinds of targets and goals into account, like the sustainable development dimensions, the more difficult it is to substitute, the more difficult it is to trade, right? To design a trading system that would do that substitution for you. So, normatively speaking, it's good to take these goals into account. It will help us counter deterrence. Thank you.
Okay, I believe we do have time for one more question at this point. The question is, are you considering potential cascading co-benefits of GGR approaches? The example that was given here by the questioner was biochar in terms of aspects such as organic waste management, reduction of fertilizer use, increased potential for food security.
Yeah, the idea of co-benefits came in several of our discussions, and we were very encouraged at the sense that at a small scale, this is sort of sub a gigaton a year, I'm talking about as small, some GGRs seem to offer co-benefits, and also by the enthusiasm amongst our workshop participants for the idea that those co-benefits should be considered, possibly even be brought to the fore in supporting those GGRs in going forward, rather than the promises of carbon removal, which were actually less secure. So for soil carbon recovery, for example, there's very clear co-benefits in food production, in biodiversity, but we really do not know for sure that carbon is going to stay there in the face of the likely climate change that we are already committed to. We also can't guarantee that it's going to stay there if the financial management regime changes and it becomes attractive for a farmer to plough up that land again. So, yes, we're very keen to see co-benefits. We saw it as one of the, it's sort of buried in the recommendations, but the idea of using co-benefits as part of the funding mechanism to get GGRs to happen in practice alongside continued emissions reduction was very much in our minds.
All right. Thank you very much for that, Duncan. We are at the 1 hour mark, and so we're going to wrap it up at this point. First of all, I'd like to once again thank our three speakers from Lancaster, Nils, Duncan, and Becky. I apologize to everyone for the technical difficulties in our new normal. Of course, this is something we'll probably have to roll with, but I appreciate everybody's grace in staying with us, and I appreciate the excellent questions. And as always, there's never enough time to field all of the questions, but that's encouraging also because there's a lot of good thinking going on in this context, and this is obviously a discussion that has to continue as we determine the role of carbon dioxide removal in terms of climate policymaking. So thank you, everyone. I hope you can join us in the future. Stay safe until we see you next time. Goodbye now.